Okay, welcome back, friends. So in the last class, that was in part 1 of ODBC with IIB node instance, we have learned how to create a ODBC source and then how to associate it with a broker instance by making use of MQSI set dbpams command. In this class specifically, I will take you through the toolkit, like how do you implement a node, ESQL based compute node, so that it will make use of a data source connection, DSN, and then interact with the database. So let me share the screen. Okay, there you go. So this is a toolkit on which I'm going to work. It's a Eclipse toolkit for IIB. Again, I say it's IIB version 9 that I'm making use of. So the first thing what we are going to do, see, in order to follow this class, you have to watch my previous video. My previous video would be specifically like how do you create a ODBC adapter in Windows system, and then how do you associate with a broker instance by making use of MQSI set dbpams in the command console. So in this class, I'm going to create an application. So a new application. So let's name as DB. It's like DB interaction, database interaction, right? So database interaction example. So it's DB inter app. The name can be anything. Don't mind. If the name is looking funny, don't mind. Okay. Let's create a message flow. Message flow. And to make this message flow look very simple, I'm making use of MQ nodes here. So specifically, MQ nodes as a transport protocol specific nodes, MQ input and MQ output. Okay, I want to make it simple. And then how do you get interacted with the database, specifically to fire some DML SQL commands. You have to make use of a ESQL compute node. So it's a part of the category called transformation. In the palette, you have the categories. Transformation is one of the category. Inside that, you have the compute node. So it's a ESQL compute node or a normal compute node, whatever you want to call it. And then make the connection. The out of the MQ input node gets connected to the in of compute node. And there are a number of out terminals for compute node. The basic out terminal that we make use of here is out. See, there's a lot of explanation that I can give on why they are like more than one out terminal. What is the use? It would be on a different class, but I am making use of just out terminal over here. The default terminal is out here, getting connected to in of MQ output node. And next thing, we have to give like some mandatory properties in the MQ input node. The mandatory property is, what is the queue name? So the queue name, let me give the queue name as input queue, and then output queue name, I'm giving it as out. And then what kind of message you're going to send as input. So let me quickly give the input message parsing. Let me make a simple message format. Message is an XML message. Okay. So making use of this message flow, I'm going to insert a record in the employee table of DB sample database that we have created in the previous class. Again, I'm saying if you want to follow this class, you have to follow my previous class where I created a database and a table. So right now I'm going to insert a record inside the employee table of DB sample database. So my record field values are going to come as a XML request, XML input. So let me create the XML input quickly. So not bad. And XML input, let me give it as employee is my root, and then like E number, let me give it as like 9001 E number, and E name, let me give it as, okay, let me give it as Trump, and ECT New York. And then we have to end the root or the parent node. Yes. Yeah. So here we have created a employee table, employee XML. Let's save it. I'm going to save it on the desktop. I'll name it as employee.xml since it's an XML message. So save a type as all files, save. So now we have the XML message ready. We'll send it as input, and whatever the values of the fields E number, E name, and ECT are, they are going to get accommodated into these fields E number, E name, and ECT of the table employee. So how do we do that? It's very simple. So before you try to write any code inside the ESQL compute node, the basic thing you need to do is that you have to give some values, mandatory values inside the compute node properties, which are related to the database interaction. So the main property is data source name. So this data source is nothing but the DSN that you have associated with the broker. So if you see the DSN name in the MQSI set DB PAMs, you have used this DB sample. You have to make use of the same thing, DB sample, right? This is the mandatory property that needs to be set on the compute node. Again, I say it's data source. So in the property value of data source, you are going to give the DSN name that you have used to make a connection of the database to the broker instance, and then start writing the code. So the code would be simple. See, we are not worried about what would be the output message. So the output message can be anything. The main aim of this class is to send some values or insert some values to the database. So let me copy the message headers so that I will send a success message whenever the database records are inserted. I want to send the success message. But how do we insert it? It's just like, it's a SQL command that you need to know. It's just like insert into. Let me write the basic SQL command which you write in as part of when you're trying to execute a SQL command inside DB2 or any database specific command console. What is the command that you are going to write? I'm going to write the same command, and later I will make the changes which are needed for like IIB, like ESQL specific syntax needs. So insert into, what is the name of the table? Name of the table is employee, and we give the values. Okay, let me write everything in capitals. Insert into, again I say it's not mandatory to write in capitals, but I am writing here in capitals. There is no harm in that. employee values. So we are not going to hard code the values, but where are we going to get the values from? We are going to get the values from the input message tree. So how do we access this? It's input root dot, what is the domain? Domain is XMLNSC dot, what is the root child? It's employee, and what is the first column? E number, that is number, right? And then input root dot XMLNSC dot employee dot ename, then input root dot comma, you have to remember to add a comma, input root dot. I'm making use of content assist over here. Content assist is going to give you the syntax of input root or output root or any functions that you make use of while ESQL coding. You can make use of content assist. Content assist, you will you can make use of content assist by making use of control and space. Then it will show you the options. Here you see I made use of control space after X, then it's showing me the what are the options. I will make use of the domain XMLNSC dot employee dot ECT. Okay, so I'm done with the query. Okay, but here we have to remember one thing. See, it does not work like this. Insert into employee directly does not work like this. You have to add something else. Insert into a keyword called database dot the schema in which this particular table exists. So the schema here is the username. So if you have not created a schema before creating a table in a database, then the username would be the schema name. In DB2, specifically I'm talking about DB2. For example, if you see here, the steps involved were first I created a database and then I connected to the database, and I did not use any statement that creates a schema. Schema is a division. It's like it's a division between, like it's like a folder. If you are good in Windows, you have like different folders into which you can add a file with the same name. Let's suppose there's a folder A, there's a folder B, and you want to add a file with the same name to A and B. Yeah, it's possible. But if you have a single folder called A and you want to add two files with the same name, it's not possible. The same thing is here. Schema, it is used to like make a differentiation. It is used to make like some different compartments in a single database. So here I did not make use of a statement called create schema and schema name, but internally it selects the username specific schema and creates this employee table over there. So here the username is IIB Guru. So a schema called IIB Guru is already created, and under IIB Guru it's employee is a table. Let me quickly show it through MS Paint. So it's like this. Let's suppose this is a database. This database name is DB sample. Then we have, let's suppose this is table. The table name is employee. Then where is the schema? Schema sits in the middle. So this is the schema. So you can have many schemas. Okay, so here the schema is, the schema is, in this case it's IIB Guru, right? So this schema might be something different. it might be XYZ. And here in the XYZ schema, you may have one more table with the same name, employee, but the same name, employee. But this table employee and this table employee are different. Even though they are existing in the same database, they are different. They are treated as different. Okay, so that's what is an explanation about schema. So here in the code, we are going to use database.schema name. Schema name, as I told, it's IIB Guru dot employee. Done. So whenever, like, let's suppose we saved this, we built this, and we deployed it. And whenever we try to run this message flow, and a database, a keyword called database is like when the execution encounters this keyword called database, it immediately checks what is the data source name, DB sample, and what is the database associated with this DSN. It's going to evaluate that database, and then it's going to like do whatever operation is mentioned over here, or whatever SQL query is mentioned over here. So that's it. Save, and then okay, this warning, you can neglect the warning. What does it say? Say unresolvable database table reference. No problem. So it only resolves these values during the time of execution or when you try to run this code. But we also thought of sending a success message if this particular statement executes properly. Obviously, if this statement does not execute the message, success message, there's no chance that the success message will be executed, because the success message is a subsequent statement after this insert query. So we'll write set output root dot xmlnsc dot database, let's say database insert status is equal to, write it as success. Okay, so if this particular statement executes correctly, then it will execute the subsequent statement. If this does not execute, obviously there's an error, so there's no possibility that this particular statement will be executed. Okay, so right now we are ready with the message flow. So let's give some breakpoints so that it would be easy when you are trying to test it. So save everything, and then if there are any flows that are deployed in the execution group, just delete them. It's not mandatory that you have to delete all the flows, but I am deleting the flows because my other flow might be using the same queue names. So here, the queue name which I am using in should be a queue inside the queue manager on top of which the broker is running. IB9 queue manager, QMGR is the queue manager. I have to make sure that this in is a queue and out is a queue inside IB9 QMGR. So let me deploy it. I can deploy it in many ways. As I showed in the first class, it may be a direct deployment of the application, or it may be creation of a bar file and then deploying it. There are a number of ways. Okay. So now once you deploy it, since you have the breakpoints here, you have to give the debugger, launch the debugger, and then let's test it. So first, I have to make use of RFH util for this. So I have RFH util. I think I have it. Yes, I have the RFH util. And then load the names, queue manager. I have IB9 QMGR. Load the names, then the queue names will also be loaded. Yes, I have in queue, and then try to put the input message. The input message is this employee. This is saved on the desktop, so open. On the desktop, let's first see whether this particular message is syntactically correct. Yes, it's syntactically correct. And then you will choose the message employee. So the desktop users IB group desktop employee. Okay, let's check it in the data section. XML, yes, it's correct. You can also go for a parsed view and see, yes, the parsing is 100% correct. Then try to write the message, and you can see the broker toolkit pops up, and then you can see, okay, the first time you try to execute this message flow, it asks for this edit source lookup path. You have to give the container, message flow container, that's the application which contains this particular message flow. Hope I'm not too fast. Okay, so please do comment if I'm fast. In that way I will make myself slow, and then we can see what's a message. It's a message as a properties, the protocol specific headers, which is MQ here, MQMD. Okay, we have all the records that we have sent. Yes, and then we can go inside the scope of this ESQL compute node ESQL. So you just need to click here on the thread which is running right now, get into the scope of the ESQL code, and then the headers are copied to the output, and okay, the statement has executed. But I want to show you one thing here. It's very important. Once the statement got executed, let's check whether we have the record inserted or not. So to do this, I'm going into the command console of DB2, select star from employee. Oh, I already have that statement. See, there's only one record. There's only one record. You must be thinking like, this statement is executed, and then why do we not see the record here? The reason for me to stop here and show it is that only when the execution comes out of this compute node, then this transaction is committed. Before it comes out of this compute node, the transaction is not committed. So the subsequent statements after this database insertion, if some of the statement throw an error, then there would be the rollback. The rollback will be happening. So it's not committed until and unless the complete code in this ESQL compute node is executed properly. So now, okay, this is executed, and let's see, hoping that no. Okay, there's a small change. Okay, let me finish the flow. Okay, I finished the flow, and then let me see. Yes, so it has to finish the flow. The reason behind that, I want to explain it to you. Yeah, there's a small change. It depends upon the property called like transactionality. Here in the compute node properties, there is a property called transaction, and if you make this transaction as commit, then in this case, whatever I told previously, it holds good. Let me show you. I made it commit, and I deploy it, and let me change the values in my input. Let me change it as 9010, and now change it as Modi, and then changes as not, it's not New York, it's New Delhi now. New Delhi, save it, and then let's try to run the flow now. So you have to choose again the appropriate file, employee, this is the same employee, yes, employee, write it. And now get into the scope of the compute node, run this. Yeah, this insert statement is done. Now if you check, you don't find the record. As I told, you have to get out of the scope of this ESQL compute node successfully. Yes, you come. Now let's execute. See, you got the third row, third record. Why? Because the transactionality here is showing as commit. So once the complete code in this particular ESQL compute node is executed properly, all the database specific transactions would be committed. It will not wait for the complete message flow to finish. Okay, so that's it for now. So I hope that you have followed my class very keenly, and then I also expect you to please subscribe my channel, give a comment. If at all I'm fast, just do comment so that I can reduce my speed, but please comment, please like, please share. Thank you.